So another example next, show that log of x base 8 equals 2 out of 3 log of x base 4. So the question goes so that log of x base 8 equals 2 out of 3 log of x base 4. So what do? We are going to say let log of x base 8 equals p. I'm just starting with that one. We use now the index law, what we have been saying about it. So what happens, this becomes x equals 8 power p. Now try to see, what are they looking for? Which log is there? I can see there is log to base 4. Then we are going to say taking log to base 4 on both sides. Taking log to base 4 on both sides. So we are going to have log of x base 4 equals log 8 power p to base 4. That's the step which you call taking log to base 4, because that's what is in the question there. That's what they want us to have. But if it was having log to base 3, I could also say taking log to base 3. So always by the idea of what is there. So what we're going to do, we apply this one from the rules of logarithm comes log of x base 4 equals p log of 8 base 4. So 8 has a relationship with a 4. Think of two numbers. When I multiply, I get 8, but must have it to that. So we've got log x base 4 equals p into log of 4 times 2 to base 4. Then we apply the same rule. When we are multiplying numbers of the same base, we do the addition. This becomes log of x base 4 equals p log of 4 base 4 plus log of 2 to base 4. We are coming to that. So what happens is this. Log of 4 is the same as 1. So we are having log x base 4 equals p into 1 plus log of 2 to base 4. Now, think of a number. When I put it here, it brings the same after. So, unrelated to 4. So this is the same as, I can look at log of x base 4 equals p into 1 plus log of 4 power a half base 4. Because we say that any number power half is the same as the square root of that number. Equally, when I say 4 power half, I'm talking about the square root of 4. What is the square root of 4? Is automatically 2, which is here. So that thing is related. So I bring this one here. Log x base 4 equals p into 1 plus a half log of 4. But log of 4 is the same as 1. Log of 4 is the same as 1. So what are we going to do there? We are going to have log of x base 4 equals p into 1 plus a half. Then we apply the rules of fractions. We are going to get the LCM. So what is the LCM here? So the LCM here is 2. So what are we having? We are having log x base 4 equals p into, the LCM is 2. 2 divided by 1, you get 2. 2 times 1, automatically you're getting 2 plus. 2 divided by 2, we are getting 1 times 1, 1. So we are having log of x base 4 equals p into 3 out of 2. So if I want to make p alone, I multiply out by 2 out of 3 everywhere. Can you still go on? Log of x base 4 equals 3p out of 2. How can I remain with p alone? So I'm going to take the reciprocal on both sides. Say times 2 out of 3. What I've done there, also multiply it here. 2 goes, 2 goes, 3 goes. I remain with p equals 2 out of 3 log of x base 4. But do we know our p from the start? What was our p? Our p was already log of x to base 8. We said therefore log of x to base 8 is the same as 2 out of 3 log of x to base 4 as required. That's how we normally prove those numbers in that scenario. So they want to buy your idea that are you quizzitant? Are you used with the way of using these indices? So when you apply that phenomenon, you will come out with that one. Mathematics is all about practice. The more you practice, the more you become perfect on that. So, and mathematics is enjoyable. It's very cheap. Whatever course you're going to do, you are going to be applying all these types of mathematical elements. So we can clean the blackboard and we proceed and clean our whiteboard. Go to our example. So example next. Example next also goes prove that log of x base 6 equals log of x base 3 all over 1 plus log of 2 base 3. So they want us to prove. When it comes to prove, you can even start from any side. Proving, you can even start from the right hand side or from the left hand side. But for this scenario here, they have said that prove that log of x base 6 equals log of x base 3 all over 1 plus log of 2 base 3. What are we going to do with this? We are going to start from, I'm going to start from the left hand side. We still use the index law, what we have been saying. So I'm going to say, let log of x base 6 equals a p. So this becomes x equals 6 power p. See, what is the base there? The base is 3. That means I'm going to introduce log to base 3 on both sides. You can say taking log to base 3 on both sides. On both sides, what are we having? We are having log of x base 3 equals log of 6 power p base 3. So what happens from another law of logarithm? This one is being driven to that side. So what happens? We're having log of x base 3 equals p log of 6 base 3. Now we also break 6 as a relationship with 3. Look at that number which has got a relationship. So I've got log of x base 3 is the same as p into log of 3 times 2 to base 3. When we are multiplying numbers of the same base, addition arises. So we come log x base 3 equals p into log of 3 plus log of 2 3. So we move on. What happens with this? Log of 3 to base 3 is the same as 1. So we apply that one. We easily substitute. We're getting log x base 3 equals p into 1 plus log of 2 to base 3. What we're going to do, we are free now to open by pushing in that p. So we're having log of x base 3 equals p plus, or you can make p alone because that's what you want. You cannot, there's no need of you to open. Just dividing throughout by that. dividing through by that, because that's what they want here. So we are going to have p alone equals log of x base 3 all over 1 plus log of 2 base 3. But do we know our p? From the start, we are the one who said, wait, log of x base 6 equals a p. So where there is p, bring in back the original thing. So therefore, log of x base 6 equals log of x base 3 all over 1 plus log of 2 to base 3 as required. That's how we do such a kind of analysis. Always just, I want you to look at that together with the idea of the indices. That's what we have been looking at. Then we are going to look at another example. And maybe the last one on logarithm. Others you can go and check in your books and you see how those things are supposed to be practiced. Mind you that practice, the more you practice, the more you become perfect. But if you don't practice, you will not become perfect in that. So let's move to another example. If log of x base 3, if log of x base 3 equals p, and log of x base 18, and log of x base 18 equals a q, show that log of 3 base 6 equals q all over p minus q. So want to show that after given these conditions, they want you to show that log of 3 base 6 equals q all over p minus q. So the same way how I've been doing that using the laws of indices. So we're going to say log x base 3 equals p. We can make x alone from the index log x equals 3 power p. I say this is the first equation. Still, come to the other one. Log x base 18 equals a q. What is x from the index log? 18 power q. This is the second equation. So you can see that we have got two equations related in form of x. All of them are in terms of x and x. What comes there? Equation 1 and 2, they are equal. You can say equation 1 equals equation 2. It means we are equating them. So can we equate 3 power p equals 18 power q. So you can see what is here. It is log to base 6. That means we're introducing log to base 6 or taking log to base 6 as it is being instructed there. You can see taking log to base 6 on both sides. That's what we want to be taking there. Can we take there? So we are going to have log of 3 power p base 6 equals log of 13 equals log of 16 power q still base 6. So from our rules of logarithm, when the power is up, is being dropped here. So what happens? It becomes p log of 3 base 6 equals q log of 18 base 6. Now you can try to 18 as a soluble with a 6. So we create it in terms of that. We look at the products of that. P log of 3 base 6 equals q into log of 6 times 3 base 6. 6 times 3, you are getting 18. It means we have not tried to change anything about it. but we are creating something related to that base. Again, we apply our rules of logarithm. When we are multiplying numbers of the same base, what do? We add the logarithms. So we are going to apply that. We say P log of 3 base 6 equals Q into log of 6 plus log of 3 6. We have not changed anything, we're just applying our rules of logarithm. So what we're going to do, log of 6 is the same as 1. We now substitute it. We say P log of 3 6 equals Q into 1, because log of 6 is 1, plus log of 3 6. Then we are free to open the brackets by pushing in that Q. We are having the P log of 3 6 equals Q plus Q log of 3 6. Now, there is something which is common. Log of 3 base 6 and log of 3 base 6, they are common everywhere. Bring this one, it is on the left hand side, and it is positive. When the crosses an equal sign, it becomes a negative. So what do we have? We have P log of 3 base 6 minus Q log of 3 base 6 equals a Q. So what is common is log of 3 to base 6, because it is appearing here again there. So we factor it out. Log of 3 base 6 into P minus Q equals a Q. So our interest is to make log of 3 base 6 as they have already instructed, to show that if it can bring that. What we're going to do, we are going to divide by P minus Q on both sides. We are going to remain with log of 3 base 6 equals Q all over P minus Q as required. That's how we do a showing. When they show, don't gamble, avoid gambling. Just follow the right path. You will see everything coming out as it is. Don't force it, because we're interested in seeing all those principles that